In this video, I'm going to show you how to use C++ Builder exe3 and FireMonkey to work with 3D models. There's a T-Model 3D component that's available, and it supports different model formats, DAE, OBJ, and ASE files. Let's create a new FireMonkey 3D project. And we can go down to the 3D shapes in the tool palette, and the last one we'll see is a T-Model 3D. We'll place that in our project. So this is the container that allows us to load model files. The important property here is the mesh collection property. So we'll click the property editor, and it allows us to load, again, either ASE, DAE, or OBJ model formats. I've got a model of the Earth. It's a Collada DAE file. So we'll open that. And then in the editor, we can use this trackbar to scale the object. We can use these arrows to move and place the model in the space. And we can also use the mouse to rotate the model around. And we're done. Click OK. And now we've got our planet Earth model. The model is loaded, and also a light material source with a texture is loaded from the model file. We can look at that texture. Here it is. And the model is dark. We can scale it. You can go down and say, for example, let's set the scale to be, and the Earth doesn't quite fit, so let's change the Z position to be further away. We'll move the Earth away from us. And we can also change its X and Y position. So let's move it down a little bit. How about 15? We'll put it in the center, more in the center of our form. Now the model is not lit, so we can drop a light into the scene. And here's our light. In this case, it's a directional light. It was placed over the top of the object. Now we see Antarctica showing up, and it looks like a little bit of South America there. And that's how easy it is to start adding a model into your application. Of course, there's much more that you'll want to do to manipulate the model. You'll want to be able to rotate it, zoom it. And for that, we'll load a project that I've already built called CPP Planet Earth Model Demo. So we'll load that pre-built project. So here we've got several components. We have a camera. We have a 3D form, which is using the camera. You saw that in an earlier video. We have two layer 3Ds, and layer 3Ds are used in a 3D application to place 2D controls in the 3D space. So in this case, I've got an arc dialer, some speed buttons, a trackbar named TB Zoom, and we've got another layer. And inside of that layer, we've got the model 3D and the texture, and that's where the Earth comes in. And we've got a timer. And I've positioned the model 3D closer in and set its scale value so that it shows up. Now these buttons are used to manipulate, rotate, and zoom in and out with the trackbar. So let's take a look at this in action. We can use the arrows to rotate. We can rotate in the Z-axis by using the arc dialer. And we can zoom in and out by using the trackbar. You can actually go past the planet Earth, right through it. So let's see what's going on under the covers. Again, as I did before, I put the model 3D and loaded it into the mesh collection. So each of these buttons, you saw me using those to move the planet, and the arc dialer to do a rotation of the Z-axis. I have two events, a mouse down on the button and a mouse button up that I share with each of the buttons. So up, right, left, and down. And then there's also the zoom trackbar where I hook the on-change event. So as I move it, you'll see I change the camera position. So let's go look at the event handlers. When I mouse down on the 4 different buttons, I set a global variable BTN to know which button was pressed, and I start a timer. And the timer is used so that as I hold the mouse button down on each of those speed buttons, I want to keep rotating in that direction. So I enable a timer to do that. And the timer is back over here It's a non-visual control, just like the light and the camera. And it's got an interval of 25 milliseconds. And it's got a timer event. And the timer event says if, depending on which button is clicked on as the mouse is being held down, I'll keep rotating either the X or Y rotation angle by 1, either in a positive or negative direction. And then if I do the mouse button up, I let off the mouse button, then I disable the timer so that it doesn't do any more of those rotation operations. So it's a nice way not to have to click the button each time and do the rotation each time. You'd be clicking forever. I can just hold down the left mouse button on one of the speed buttons and have it do the right thing and move in that direction. For the trackbar, using that for zoom, I simply am going to change the position vector of the camera. So the camera is going to be moved in and out based on the value coming from the trackbar. And the arc dial, as I move it, it's on change event. I simply change the Z axis rotation angle to be the value of the arc dial as I'm circling in a 360 degree circle. When I create the form, so the on create event, I'll save where the camera vector currently is pointed. So camera 1 position vector, so that I can know where I was, and then later update the camera vector and scale it for the value from the trackbar. So taking a look at the header file for the form, we see that it inherits from a form 3D. All the components are defined. The event handlers are defined. And I have 2 public variables in my form class. One is the camera vector called cam vector. It's a T-vector 3D. And I've got a btn variable, which is which button that I clicked on, and that's an integer, and that's used in that switch statement. So the code, again, is just here to handle the clicking of the buttons and the rotation with arc dialer and the zooming. Very straightforward and simple C++ code. And again, we can run this, and it works on Windows 32. Let's go and add it to run on 64-bit Windows. Here it is running on 64-bit Windows. And also on OS X. So we'll compile the project. It gets deployed over to the Macintosh. And here's the application running on the Mac. And if we wanted to extend it, we'd put things like a moon and stars and other things in the application. So that's how easy it is to take a model that you might have and add it to a FireMonkey 3D application. It might be a model of a city, of a house, of a piece of furniture, of a vase or something. And then using this little set of components on a layer 3D so that we have a little control panel for doing the zooming, rotating, and so on. We could add to this further. We might want to add buttons for panning instead of rotating, so we can move the Earth to the right or left to look at other objects in that space. But I'll leave that for you. FireMonkey makes this all possible by having this T-Model 3D component. It's just a component wrapper over a custom mesh. There's information on the doc wiki and in the online help about using T-Model 3D, consisting of a collection of meshes. You can put that 3D on a 3D form, or you could put that T-Model 3D in a 3D viewport in an HD application. It's your choice. And there's also a tutorial about importing 3D models, and it talks about the mesh editor, importing the model, manipulating the model, adding a light and a camera, and so on. It's easy to do with C++ Builder exe3 and FireMonkey running on Windows and Macintosh.